Alright, let's start with this first one. The first one is KMNO. We need to determine the percent composition. So the first thing we need to do is find the gram formula mass. I just did the gram formula mass, and I'm not going to spend any more time teaching how to do gram formula mass. If you need to know how to do that, go back and watch the other video. Okay, to find the percent composition, we always want to start with writing our formula, part over whole times 100. And the part that we're looking for is going to be the percent of whatever that thing is. So we're going to look for the percent of potassium. So the percent of potassium is going to equal the part that is potassium. Now, these are the three parts. 1, 2, 3. They add up to the whole, which is down here. These are the parts. So the part that's potassium is going to be 39 over the whole thing, which was 158, times 100. Okay, so this is going to equal 24.7% potassium. Now, I'm going to have to do it over here. I'm going to do the percent of manganese, and I'll do that in green. Percent of manganese is going to equal the part that is manganese, so that's the 55, over the whole thing, which is 158, times 100. And that's 34.8% manganese. And then finally, we can do the percent that's oxygen. I'll do that in red, so it's in a different color. We're going to do the part that's oxygen, which happens to be 64. We're going to divide it by 158 times 100. And you get 40.5% oxygen. Now these three numbers, let's highlight them if I could find a highlighter. Okay, these three numbers, 24.7, 34.8, and 40.5, should add up to 100%. So that's another way to check your math. Alright, let's tackle the next problem, which is hydrochloric acid, or HCl. We have hydrogen, we have chlorine. We're going to calculate the gram formula mass, and I got 36 grams per mole. We're going to make sure that we write our formula down, percent equals part over whole times 100. And then we'll tackle the percent of hydrogen, which is going to equal the part that's hydrogen is 1 over 36 times 100. And the percent of chlorine, which is going to be the part that's chlorine, which is 35 over 36 times 100. That gives us a 2.7% hydrogen and 97.2% chlorine. And these two guys are very close to adding up to 100%. They're 99.9%, which is close enough in my book. Okay, for the next one here, I'm just going to actually write the answers in so that you have them. Check your work. If you need to see it in more detail, come see me at X time. Alright, so here's problem number 3 worked out for you. You can see just real quick, we've got 3 different percentages. They all add up to 100%, so that's the way I checked my work. I have my gram formula mass written over here on the side. It came out to 148 grams per mole. It's hidden behind my box. So if we were to write the answers in, this would be 16.2%, this one would be 18.9%, and this one would be 64.9%. Okay? Alright, so the first thing I did was I counted everything up and figured out the gram formula mass. I'm going to move that over to the side. I always write my formula down next because I'm dealing with percents. Alright, after I write my formula down, I'm going to calculate my percents, which are the part divided by the whole. So here's the part. I'll get a little pointer out. Part divided by whole. Part divided by whole. Remember, I'm getting my parts from over here, 42, 12, 31, and 64. 42, 12, 31, and 64. And I'm going to get my percentages, which added up to close to 100%. Okay, for this one, once again, I did the gram formula mass, and I'm just going to move that to the side. Unfortunately, it's attached to the other thing, so I'll have to make another box, but we'll put that over here. Alright, so then I went ahead, I wrote my formula down, and then I got my percentages of 15.8 for aluminum, 28.1 for sulfur, and 56.1 for oxygen. And go us, it adds to exactly 100%. All right, just like always, we start this question number 6 with calculating the gram formula mass. Now let's discuss what this question is actually asking us. It's asking us how many grams of oxygen can be produced when you decompose. Decompose is another way to say break down 100 grams of KClO3. So there's going to be 3 parts to this KClO3. It's going to break down into potassium, chlorine, and oxygen. So we're going to figure out what the percent of this is going to be potassium, what percent is going to be chlorine, and what percent is going to be oxygen. Okay, so I went ahead and I calculated the percentages for each of those parts that I just showed you, the potassium, the chlorine, and the oxygen. If we have a 100 gram sample, let's get a pen. If we have a 100 gram sample and 32% of that 100 gram sample is potassium, then we can just do the math. We can take 32% of 100 is going to be 32 grams. So if you want to know how to do the math, you could just do 0.32% times 100 grams is going to equal 32 grams of potassium. You can do the same thing with the chlorine and the oxygen. So we've got 28.7% of 100 is chlorine. So that's 0.287 times 100 equals 28.7 grams of chlorine. And then finally, I'll do it in blue, we've got 39.3% of 100 is going to equal oxygen. So that's 0.393 times 100 equals 39.3 grams of oxygen. Alright, just like all the other problems, I started with just simply taking a gram formula mass for the formula because we're going to need that. Alright, in this case, all I had to do was find out the percent of iron because the question is asking about iron. And I calculated that the percent of iron is 70%. Well, if you have 70% of your sample is iron, then if I have a sample size of 25 grams, 70% of 25 grams is how much iron I'm going to have. So I'm going to do 0.70 times 25 equals 17.5 grams of iron. Alright, there's your gram formula mass. I'm going very quickly with the gram formula mass now because we do not have to spend any time learning how to do that. So I'll stick that over there in the corner so I have it. So I quickly figured out what the percent of silver was by taking the part that was silver, dividing it by the entire thing, which weighed 248 grams per mole, and I got 87.1% silver. Now they told us the sample size was 125 grams. If you have 87.1% of 125 grams is going to be your silver, then we just have to do the math. We take 0.871 times 125 equals 108.9 grams of silver. And that's what they're looking for. So remember, this sample size is the whole thing. So as long as I have the percents, I could figure out what percent of that sample size is going to be either the silver or the sulfur. We weren't asked about sulfur in this question. We were only asked about silver, so I did not have to do the percentage for every single one.